Statistics scores. Scores on the final exam in a statistics class follow a normal distribution with a mean of 82 and a standard deviation of 5. A normal distribution is a continuous distribution. The first step in solving a normal distribution is to draw the bell-shaped curve and label the mean and the standard deviation. The mean is 82 and the standard deviation sigma is 5. Ron, who took the class, scored 88 on the final. What is his z-score? The z-score is computed by taking the value x minus the mean mu divided by the standard deviation sigma. The score for Ron is 88 minus the mean is 82 divided by 5. Computing this, we get 1.2. Ron's score is 1.2. It is higher than the mean because the z-score of 0 is in the middle. 1.2 is on the right-hand side of 0, on the right-hand side of the mean. And so his score is well above the mean. The mean is 82. His score is 88. How many standard deviation away from the mean is it? This number, z-score, is the number of standard deviations away from the mean. And since it is positive, it simply say that it is on the right-hand side of the mean. Precisely, it is 1.2 standard deviations on the right-hand side of the mean. Dan also took the class, and the z-score of his final is negative 2.4. What is Dan's score? Compare his score to the mean. From the formula z equals x minus mu, the whole quantity divided by sigma, we can isolate x to get x equals mu plus z times sigma. In this case, we have Dan's z-score. We just need to find his real score x. Knowing that the mean is 82 plus the z-score is negative 2.4 times the standard deviation is 5. We have 82 plus negative 2.4 times 5 is 70. And so this is Dan's score. His score is below the mean because remember the mean is 82, and that is the reason why his z-score is negative. A negative z-score means the value is below the mean. A positive z-score means the value is above the mean. Julie took another statistics class with a different professor whose final scores follow a normal distribution with a mean of 75 and standard deviations of 6. This is a different normal distribution with a different mean. The mean in this case is 75, and again, we label the mean from the peak down. The standard deviation this time is 6. Julie's score is 84. 84 is a little bit on the right-hand side of 75. We would label 84 and draw the vertical line. Which of the two scores, Ron's or Julie's, is more impressive? Remember that Ron scored 88 and Julie's score is 84. However, we cannot compare 88 to 84 because they took different exams. One has a mean of 82, standard deviation of 5, and the other has a mean of 75 and standard deviations 6. To compare the two, we would need to standardize them. We standardized Ron's score already, 1.2. We next need to standardize Julie's score. Z equals x84 minus mu mean 75. Take this and divide it by the standard deviation sigma 6. And this is 1.5. After we compare the two, we have the two z scores. Now they are on the same scale. We can compare the two. 1.5 is greater than 1.2. This means Julie's score is better. Julie's scores is more impressive than Ron's.